Hi grade 8s. Today is the start of a brand new section, and that's the section of fractions. So you can start a new page, new heading, and please start with an open mind, because most people hate fractions, but it's because they really don't give them a chance. Now, ultimately, at the end of the day, most of these questions I just use my calculator for, if I was needing to solve them. But in grades 9 to 11, we're going to need to be able to manipulate fractions and multiply fractions and divide fractions that have algebra in them. And unfortunately, your calculator can't do algebra. So we're literally going to pack away our calculator for this entire section, because we're building the skills that we need for the higher grades. So I will use my calculator to check my answers always, and if there's a massive, two big numbers that I'm trying to calculate, I'll quickly cheat on my calculator. But otherwise, every single one of these examples and exercises I want us to do without a calculator, simply to build our skill set. So I've divided this into a couple of subheadings, and the first subheading is the basics, and there's a couple of subheadings under this, just to start off with our definitions being the first one. So don't forget to hit pause. There are a couple of drawings along the way. Hit pause, draw the drawings quickly, because it's really important to have good notes in a section like this. So let's look at the definition of a fraction. Basically, a fraction just means part of a whole. So a whole would be, for example, an entire cake, or an entire kilogram of flour. But what happens if you don't have an entire cake, but you have a part of it? So a fraction literally just means part of a whole. Now, every fraction has a top of a fraction, which is called the numerator. You would have heard these words before, I'm sure. We don't really care about these big words, but sometimes we use them. So the top is called the numerator, and the bottom is called the denominator. Now, to be honest, fractions come down to one thing, and that's understanding what the denominator means and what the numerator means. So what does the numerator mean? A numerator means how many parts you have. So if you're talking about a cake, it'll be how many parts of cake. So how many parts, I'm just going to say you have. That's probably the easiest way to say it. Now, our numerator means how many parts the whole is divided into. So how many parts, I should say how many parts, so let me try that again, how many parts the whole is divided into. I'm going to say this again because I really think that if people can understand this definition, then fractions are quite easy. So the numerator, or the top of the fraction, is how many parts you have, or how many parts you're interested in. And the denominator is how many parts the whole is divided into. So let's look at an example, because I think that makes it a little bit more tangible. So what does 1/4 mean? Well, 1/4 means that basically you're going to take an entire cake, or a kilogram of flour, whatever, and you're going to divide it into 4 parts. So hence you'll notice in my little picture, I have 4 parts. Now, the numerator tells me how many parts you have. So basically this is saying I have 1 part out of 4. So you would say I have 1/4 of the cake. So numerator, denominator, how many parts you have divided by how many parts the total is divided into. Okay, now, to be honest, that's pretty much the important thing about fractions, and after that everything kind of falls into place. So let's look at a couple of other definitions which we should know. A mixed number is basically when you have a number of wholes, so you have a whole number and then the fraction part. So that's probably not a very good way of saying it, but we all know what I mean because we've done mixed numbers for a while. But basically this means I have 2 wholes, so that's why it says 2, and then after the 2 wholes I also have 1/5 of the next, for example, pizza. So this literally means 2 whole pizzas and then 1/5 of the next pizza. So you have a whole number part and you have a fraction part. Now, an improper fraction is somewhere where the numerator is larger than the denominator. So that's when our top is bigger than our bottom. So our numerator is larger than the denominator. Again, a word that you probably should know quite well by now. Now, I think I'm quite aware that in primary school, everyone loves mixed numbers, and so as soon as you get an answer, you change it to a mixed number. Whereas, to be honest, in high school, we prefer an improper fraction. The idea is that they're the same thing, but why then convert it to a mixed number if it's just extra effort? So let me just show you an example here of a mixed number and an improper fraction. 7 over 2, which would mean that basically you took cakes and you divided them in half, and you have 7 of those halves. So you'll have a look here. Here's 1, 2, 3, 4, 5, 6, 7. There's 7 halves. Now again, how I've drawn this picture, and I'm hoping that you're going to draw it and shade it, is that these two will form one whole because there's 2 halves in a whole. These two will form one whole. These two will form one whole, which means I have 3 wholes, and then I have 1 extra half left over. So we're going to talk about converting in a moment, but just to encourage you that if you get an answer of 7 over 2 in high school, leave the answer as 7 over 2. We don't think that 3.5 is any better than 7 over 2. They're exactly the same thing, but we actually are more than happy with an improper fraction. And then the last thing just to discuss is the idea of equivalent fractions. Equivalent fractions are fractions that are equal in value. Now, this is incredibly important because we use the idea of equivalent fractions in loads of applications. So if you look at an example, again, this is something you'll know, 2 over 5 is exactly the same as 4 over 10. So if I said to you, you have a cake and you divide it into 5 pieces and you're going to eat 2 pieces of those 5, that's the same as me saying to you, you divide a cake into 10 pieces and you eat 4. Now, why they're the same? Because if you multiply the bottom by 2 and you multiply the top by 2, you get the same thing. Now, this is really important. A lot of things in primary school, you were probably told what you do to the bottom, you do to the top. And that's a really important concept, and we're going to discuss that in a moment. Now, why? Because if you take 2 over 5, and if you multiply the top by 2, and you multiply the bottom by 2, you get 4 over 10. Now, why does this mean they're equivalent? Well, because what is 2 divided by 2? 2 divided by 2 is 1. So basically, you're taking a fraction, and effectively, you're multiplying by 1. And when you multiply anything by 1, we all know that it stays exactly the same. So when you multiply any number by 1, the number stays the same. So absolutely 2 over 5 is being written in a different way because it's been written as 4 over 10, but effectively you've multiplied by 1. And so it stayed the same value. So it looks different, but it's the same value. Now we're going to discuss that a little bit more in a moment. So those are pretty much our definitions on which the whole of fractions kind of rest. So let's look at question topic 1.2, which is equivalent fractions, which is just what we were talking about. So I've drawn a little picture here. These pizzas all have half of the slices shaded. So basically, if you were going to eat the shaded parts of this pizza, we would all agree that you're getting half of the pizza. But in this pizza, the pizza was cut into 2 parts, and I've shaded 1. So this is a half. Now, that's equivalent to, in this picture, I divided the pizza into 4 parts, and you're eating 2. So that's 2 parts out of 4. Now, that's the same as if I divide my pizza into 8 slices, and you actually eat 4 of those slices. And that's equivalent to if you divided your pizza into 16 slices, and you ended up eating 8 of them. You were always eating half of the number of slices. Now, this is the important idea of equivalent fractions. So what I was saying to you in the previous thing, which is really important, and I would write it down and put a nice box around it. Basically, if I multiply the top by 2, I can multiply the bottom by 2, and my fraction then doesn't change value. Why not? Because you've effectively multiplied by 1. So I'm just going to write myself a little note here. And I'm just going to say when you multiply, now I'm saying multiply, but there's no reason why you couldn't be dividing. So when you multiply or divide the top and the bottom by the same number, top and the bottom by the same number, what I'm arguing is that that means you are effectively multiplying or dividing by 1. So you are effectively multiplying or dividing by 1. Now what that means is that your value doesn't change. So I'm going to say, therefore, your value doesn't change. All you've done is you've pretty much converted it into a fraction that looks different, but it's the same value. So I'm going to say, therefore, the value doesn't change. The fraction just looks different. Now, I'm pretty sure you will remember from primary school that what you do to the bottom, you do to the top. But I'm also pretty sure that, I don't know if you ever understood why we do that. It's just something we learn in primary school and then we just do it blindly. But why are we doing the same thing to the top and the bottom? We only do the same thing to the top and the bottom if we're trying to create a fraction that actually has the same value. So if I multiply this top by 2, I must multiply this bottom by 2, because then basically I've done nothing. I've multiplied by 1. So I haven't changed the value, I've just changed what it looks like. Again, if I multiply by 2, I multiply by 2. Then I've effectively multiplied by 1. So let's look at a couple of examples. Example 1, and I must really encourage you to hit pause all the time. I type out all these things just so the lesson isn't too long in terms of the video, but you need to be pausing all the time to write these notes down. So fill in the missing numbers. Well, if these are all equivalent, which I'm assuming because they've got an equal sign, if I multiply the bottom by 3, that means I must multiply the top by 3, because then I've effectively multiplied by 1. So I haven't changed the value and it's equivalent. Now again, if I multiply this top by 2, I could have said, oh, I'm multiplying by 6 and go all the way from the beginning. But then I must multiply this bottom by 2 in this case, which is 30. Or I must multiply it by 6 and I'll also get 30. So don't forget, what you do to the bottom, you do the same thing to the top if you're creating an equivalent fraction. So 7 times what will give me 84? Well, it's 7 times 12. So I have to do 8 times 12, which is 96. Now, this is a really good example of where I would definitely use my calculator if you were concerned around, for example, 7 times what gives me 84. There's nothing wrong with picking up a calculator and going 84 divided by 7 to get 12. That we're not trying to stop you from using your calculator to do that. 8 times what gives me 40? Times 5. Now, why didn't I go 96 to 40? Because that's not an easy conversion. So I picked the easiest method. So I'm going to go 7 times 5. And 7 times 5 is 35. Again, if you don't know your times tables that well, you can always pick up your calculator. Okay, now example 2 is about simplifying fractions. We always leave our fractions in simplest form. So we always leave answers to any fraction question in simplest fraction form. That doesn't look like a W, so let me write that again. We always leave our answers in simplest fraction form. Now, again, you can always use your calculator to check if it's simplest fraction form, because you can just put there, I could literally just put 12 over 15 in my calculator and the calculator will tell me what the answer is. But we're trying to build a skill set, so let's not cheat. We can check later, but let's not cheat. Do remember that there's nothing wrong with an improper fraction. We prefer improper fractions, so I'm never going to be converting to a mixed number. So how do we simplify the following? Well, we said here that when you multiply or divide the top and bottom by the same number, so we're going to be dividing the top and bottom by the same number simply because we want to write this as the simplest fraction. So I'm going to say to myself, what is 12 divided by... Now, what number goes into 12 and 15? Well, 3 goes into 12 and 15, and 12 divided by 3 is 4, 15 divided by 3 is 5. Now, maybe I didn't guess the biggest number that went into them, so I might need to go and simplify some more. But in this case, I know that nothing goes into 4 and into 5. Okay, what goes into 27 and into 63? Well, I know 3 goes into it. Does anything bigger? So I checked and I got 9 goes into 27. So 9 goes into 27 3 times, and 9 goes into 63 7 times. Now, what happens if you didn't check 9? What happens if you had said 27 divided by 63 and you divided this by 3 and divided this by 3? There's nothing wrong with that. Then you'll get 9 over 21. And then you should say to yourself, hang on, doesn't something also go into 9 and 21? And so I'm going to divide by 3 again. And when I divide 9 by 3, I get 3. and 21 divided by 3 is 7. So there's nothing wrong with going little steps if you don't pick the biggest number that goes into your top and bottom. Okay, last one. What number goes into 20 and into 65? Well, I know 5 does, so I'm just going to check. 20 divided by 5 is 4, and 65 divided by 5 is 13. Now, 13 is a prime number, so I know that nothing goes into it. Now, you could also check those on your calculator, but remember, we're trying to build a skill set. Okay, so that's basically the basics, the definitions, and then can you convert between equivalent forms. Now we need to do a little bit more basics before we move on to our adding and subtracting.